In this video, we will find the domain and range of linear equations. Pictured are primary vocabulary words that you should ensure you are familiar with. If you're not, I recommend that you look in prior notes and possibly videos online. Number 12, what are the domain and range of f of x equals negative 37? Using a TI-30 family calculator, we don't get quite as much as we would with a graphing calculator. Yes, that's true. However, we can get enough to think this problem out. Okay, first thing we need to note is that f of x can be used interchangeably with y. So use your table and get rid of or clear out whatever is there. And just put in the negative 37. It's y equals negative 37. So negative 37 and enter. I'm going to start at 0 and use auto because we don't know what to ask for. Okay, we're just seeing where does this go right now. All right, so let's arrow down till we get to OK and enter that. Well, look at what happens. I'm going to go up and down, arrowing, and no matter what happens, y equals negative 37. This implies that the range is always negative 37. So there is no other value in that range. So we can use, or rather go through our ABCD options and see that A has a range that isn't negative 37. A, B, and C don't have that. Now, D, yes. The only item in our answer set, and using set notation, which is proper, is negative 37. So that's fine. Now that we've eliminated A, B, and C, let's look at our domain of D and verify it. It says domain of all real numbers. Now, wait a second. All real numbers implies numbers other than integers. Well, our table only gives us integers. So let's backtrack and see if we can maybe go in halves, steps of a half. So let's clear. We're going to go back. Don't worry about where you start. Let's say we can put in 1 over 2 or 0.5. It doesn't matter. So we're going to go by halves. So 1 divided by 2. Push my 2. There you go. Now let's enter again and see what happens. Yeah, half numbers. The truth is any value will work, to be honest. It's just a horizontal line. Okay, so this tells me that all real numbers would be valid and option D is acceptable, or rather verified. Okay, let's try some different calculators. On the TI-84, we will do the same thing. We're looking for domain and range. So we would put our equation into the y equals, using the y equals function. Okay, meaning that for set notation, we know f of x equals y. So go to our y equals. I'm going to clear out what we already have and simply put in the negative 37. Okay, now we could look at the table or let's just look at the graph and see what happens. So graph it. Okay, that isn't going to help us because we have a zoom issue. So it's what I had in prior. Your calculator, it may pop up right away. If it doesn't, don't think you did it wrong. Always try your zoom. So let's go to zoom. I like zoom stats, a good one, but let's do standard. So let's go 6. Okay, it's negative 37, so that's not going to do. We're going to have to zoom out or maybe zoom fit. Try 9. No, it all depends. So I'm going to arrow up, actually. You could arrow up or down. And let's try B. So I'm going to highlight the B, push enter. Still not working. So let's zoom out. You may just have to just plainly zoom out. From where I started, I didn't start at a good point where you may have, your calculator may have been at a good point. So you kind of have to play around depending on what you had in your calculator prior. Okay, let's push enter. And I'm going to go down because I need negative 37. So I need to zoom out more with quadrants 3 and 4. Okay, so now I'm going to push enter, and there you go. Okay, so let's go to trace, right? And it automatically trace is going to pop me down to the 0, negative, x is 0, where y is negative 37. This tells me that, again, it verifies I have a horizontal line. Now let's go to the table and go through that process, okay? All right, it gives you a visual of what you have. Let's think this out. If you're not sure about these things, you don't quite understand what's going on. For example, let's look at our y values. Well, of course, all of the values of y are the same. This means your range will always be negative 37 and nothing else. So we mark out all the options that do not have the singleton, which is a math term, by the way, a singleton in set notation of negative 37. So the only one that has that is option D. Now, we can verify all real numbers for the domain simply by having, well, by the graph actually. We could change the table, and if you look back at where we use a TI-30, we just made sure that our table would go in different steps, and we know it does. And our graph shows all real numbers for the domain. It's infinite. It is an infinite horizontal line which verifies the domain of all real numbers. So we could do it visually with the TI-84. We don't need to manipulate the table. Okay. Okay, for the TI-Nspire, of course, again, things are a little different, but I'm still graphing. So I have graph highlighted, option B here. Okay, you can arrow up and down or use your little cursor. You kind of have to work on that. So let's go ahead and enter for a graph. But it gives me a graph I don't want. Well, I see an old graph, but then I have the option to put in another one. Let me show you what's going on here. I can go to menu, and I go down to where I edit the graph, okay, that is currently in there. And I push enter, and it says, hey, do you want number 1, a new function? And I say enter, and it gives me f of 2. I already have something populated in f of 1. Well, what would happen is that would put 2 graphs on the same one. And honestly, you can do that if you wish, but I would rather not. So I prefer to edit my document. So I have number 1 highlighted. Notice I use the dock button. Now I'm going to arrow over, so it'll give me some options. I want a new document. I want it clean so I can see what I'm doing. Okay, so push enter, and it says, do you want to save? I don't. You may want to save your items, so if you do, go ahead and do that. So enter, and now I want to go to number 2 because I'm graphing, so enter. So now I'm fresh, brand new. All I do, or I need to do, is type in negative 37 and enter that. Of course, I don't see it. I'm going to have to zoom. Just like on your TI-84, you will need to zoom. Okay, so how do I do that? Back to menu again. Now, there are other ways to get to it, but this is just a nice system of, hey, let's go to menu and do it again on menu. Okay, so what do? We need to go to number 4, window, zoom. See, and I have my pen and it messes us up. So I need to quit using that. Go back over, go down, and you're using your little mouse on your calculator. It's a little testy too. I haven't met a TI-Nspire that doesn't have a touchy mouse here. Little center mouse grabbing and learning how to do that. For the most part, I found that everybody catches on eventually. Well, actually, pretty quickly. Okay, that all being said, I want to zoom out. I'm not, well, I could try zoom fit, which is A. I'm going to arrow up to get to it. Okay, right here, zoom fit, enter. It's still not helping me. The truth is, I should have just done a good old fashioned zoom out. Just do it manually. Right here, that's number 4. Enter. And let's see, you can use your cursor, but I'm going to go as far down as I can and keep zooming out. There it is. Okay, here we go. See how I did that? I just kept pushing, and you can do that on the 84 also. Just keep pushing enter and moving around your cursor until you get where you need to be. It can be done on both kinds of graphing calculators. Okay, so what I see is that my graph is a straight horizontal line, but the only value it has is negative 37, and that's the only range it will have. I can also show that in the table, okay? But if you look at the line, it's obvious that the line is continuous and infinite, meaning all real numbers. That's what a line tells us. It is continuous information, not discrete. Okay, it doesn't break up into pieces. So I would select option D. Now, B has a condition here, okay, on your all real numbers. That's not valid. And then the domain on A has a singleton of negative 37. That's not correct for domain. Now, the domain on C, I like it, but I don't like the range because the range should be a singleton. Well, let's prove that with a table. So go to menu and then go down to number 7. This time I'm just going to push 7 and then it'll highlight what I need and then enter because I want a split table. Notice every single value for my x is always negative 37. I could sit and push down or up infinitely. It should go on and on and on. I don't want to test to see how far the calculator goes. That's not what we're doing here. It'd be fun. You want to waste your time, knock yourself out. That's endless scrolling like we do on our phones, right? Waste of time. So, but it does verify option D is correct using the Nspire. Using the Desmos Graphing calculator, now we could use the TEKSES version or the general version, free online. It doesn't matter which one for this problem. Okay. We just simply do as we would on a calculator. Go to the first line and simply type in negative 37. Now watch what happens though. Negative 37. It doesn't do anything for me. Okay. Why? Because it doesn't know. It doesn't know yet. What are you typing in? That's what it's asking me. So I go to the first part and I say y equals. This is something we often have to do with Desmos. You have to tell it y equals. It isn't like your other calculators, where automatically gives you a y equals or an f of x like the Nspire. It isn't automatically set up for that. So you have to tell it, I want f of x. And to be honest, we can put in f of x and then put in your equal. Okay, and it's valid. The minute you see your little color circle come in over to the left, you know it's graph somewhere. You don't get a triangle error. Okay, and now how do you see it? Well, I'm going to put down my keyboard and literally go down until I see it. Or you can use the zoom out. Okay, and then we can hover over and just touch twice and it's going to show you where your 0 and negative 37 is, but it doesn't show you enough to think through the problem. Say you're a little shaky on domain and range. What does that mean? Well, remember, domain is the x values and range is the y values. Well, I only have one y value. Well, let's prove that with a table. So we go to my gear and I push table, and it's going to give me an infinite negative 37. The only difference is I cannot arrow up and down. I will have to type things in. So let's put in negative 100. All it is 37. Let's go down here and put in positive 100. Well, negative 37. So the only value for the range is, again, the singleton of negative 37. It doesn't matter which calculator I use, I will always see this, okay, because it is a horizontal line. Now, I need you to look at what it did. It started populating, okay? So if I zoom in and move things around with my mouse, I see that no matter what I do, I will always have my dots on the line, okay? It verifies our findings. Now, what is a domain? It's all real numbers. My line is infinite, and no matter what I type in, I will always get negative 37. Let's put in 2,000. Same thing. It just simply doesn't matter. How about a half? 0.5. Still negative 37. I could play around with it all day long. The singleton's the same. Any number, infinitely, any number. Pick one, doesn't matter. It's in the domain. So that will verify option D. And it also verifies because our singleton is shown as negative 37. That means the range of C, B, and A are incorrect. So again, we verified our findings of option D. Thank you for watching. If you would like the materials that accompany these videos, you can visit us at numbersareradical.com. And once again, everyone, happy testing.